Hi, I'm Simon Clifford. I work for Money Supermarket. I've recently been doing some blue-green work with Terraform, so I thought I'd share. I did some Googling when I started this, and the best I could find was to duplicate your Terraform code, which was all seemed to be done manually, which isn't very ideal. So wanted to come up with a more automated way of doing it using as few tools as possible, but using off-the-shelf tools rather than anything hand-baked. So we've come up with this approach, which uses Terraform and Jenkins to manipulate a JSON file, which is your Terraform vars file. First of all, let's start by talking about what is a blue-green. This seems to be something that a lot of people have an opinion on, and not everything matches up. So for the purposes of this example, this is what we're talking about. So we want to start off by deploying some new servers. We want to make sure that they're not accessible to live until we're ready for them to be. We want to be able to test them. We want to be able to do a controlled traffic switch. We want to be able to destroy the old servers. And of course, we want no downtime to the customer. So what does this look like? So it looks something like this. So we've got a couple of Route 53 records and ACM certificates pointing to an ALB, an application load balancer, which has a listener which does some routing based on hostname and routes to a different set of auto-scaling groups. So there's two parts to this. There's the actual provisioning of the infrastructure, the auto-scaling groups, the launch configurations, the target groups, and then there's the traffic switch as well. So if we just focus on the green boxes for now, which is the provisioning of the auto-scaling groups and the launch configurations. So our main.tf looks something like this. This is obviously a very simplified version, but we use the local file resource and the template file plugin to render a template file using our variables file, and that outputs some generated Terraform. So you'll see we've got this var.releases. So if we have a look at the variables file, then we'll be able to see that we've got this releases object, which can have one or more keys containing specific details about that release. And if we have a look at the template, so that just iterates over the releases objects, taking the key and the config for each key, creates a module with the key, or the version in this case, and then we can take specifics from that, from the variables for that release and put them in. We've also used some locals here, which can be used for some sort of predefined that don't tend to change per release. This can get more complicated if you want. You could use some conditional logic to define some defaults if it's not specified per release, but we haven't done here. This is about as complex as a template can get. You only have access to the if and the for functions. You don't even have access to an if else, which keeps it nice and simple. And then if we look at our generated Terraform, if we'd have done an apply of this, it would have created this .tf file, which we could then apply in a subsequent run. So to apply this, what we do is we just do a Terraform apply and target the local file, and then we do another Terraform apply, which applies everything. So if we wanted to do a second release, we'd just add a second key in here. So for this example, we've used V1 and V2. What we actually found was using versions specifically stopped you from being able to do things like re-release the same version but with a different set of config. So we actually went for timestamps in our example, but it's a bit too complicated to read on the screen. So here we go. So this is what the generated Terraform would look like. So we've got two modules now, and you can see that the AMI has changed to match. Okay, so now we've worked out how to build our infrastructure, to destroy it, we'd simply remove one of the keys from the releases object and just regenerate the template and then apply again. So at no point do we run a Terraform destroy, which stops things from accidentally being destroyed when you don't want them to be. So traffic switching, within a module containing the ALB, we create a listener and a pair of listener rules for that, one for the live, one for the pending. So they target the target groups which are created as part of the auto scaling group module, and they route based on the host header. So the host header for live goes to the live target group, and you can have a pending record pointing to the pending. So because you can't access the module's object directly to select a specific key from it programmatically, what we do is we also render a tgarns local in the template when we do that, so that we can then access it. So when that renders, it looks like this. So you can see the two keys for version 1, version 2, pointing to the specific target group arms. And then because we've got an object that's part of locals, then we can use a live ID and a pending ID to select the correct target arm. But what about ForEach? You may be aware that in version 12 of Terraform, the ForEach function was added to resources and data objects. However, it wasn't added to modules. But the good news is it has been added to the version 13 beta, which is out at the moment. So you'll be able to make use of that when version 13 comes out fully. So it looks something like this. So we will create a module, we call it dynamic, and that will have a for each on the releases object, which releases in each, which contains a key and a value, the key being the version in this case, and the value being the object, which contains all of our release specific properties. As well, because of this, because we're now got a static module name, we can address the sub-objects without having to do any templating of locals. So it makes things a lot cleaner. Okay, so challenges and lessons learned. So thinking about the pipeline, we need to think about when we push to Git. We don't want to push too frequently because that will create a huge change history, but we also don't want to end up with an accidental outage because live servers aren't in code. So we push up to Git when we have switched traffic so that the new live servers are in code, and then we push up once we've destroyed the old servers and removed them from code as well. So on the same sort of vein, we need to think about handling failures during the pipeline so that we don't end up with any accidental deletion of live servers. We've used create before destroy to protect any immutable infrastructure, such as auto scaling groups and launch configs, from being destroyed when we're not ready for them. I did find on some of my testing that auto scaling groups were tainted and Terraform tried to replace them. However, in certain cases, this could potentially cause a outage to production. So we found that using the create before destroy lifecycle hook did protect against this. The target groups are created with the auto scaling groups and are unique for each release. So when the infrastructure associated with them gets destroyed, so does its target group. So we just need to think about the pending listener rule to make sure it doesn't point to a non-existing target group and cause an error in the run. We try to use variables in the module source because it's the same module source and base path for each the dynamic and the static, and we want to keep the versions in line. Try to do that to maintain to improve maintainability. However, you can't use variables in the module source. And we also discovered that the target group health is not evaluated until a listener rule is actually pointing to it. This doesn't make much effect day to day. However, on the initial create, if things were a bit slow, such as the ACM certificate provisioning, then we found that the auto-scaling groups would fail their health check because the target group didn't have a listener rule pointing to it, so the health wasn't actually evaluated. It's just one of the weird quirks of AWS. So that's just about everything, I think. I'll be around for questions, but thank you very much for listening and feel free to ask anything.